I've never been a PI. I've never been through a competition to be a PI, but I do know a little bit about what it means to be a PI and what it means to be selected, since I actually select you people. So keep that in mind. I'm just going to go through a few talking points that my staff thought would be of interest to you. May or may not be, but time for you for questions and answers. I've been around NASA. Well, actually, I started at NASA in '78, but I really started at NASA and on Hubble in '76, because little did I know when I took my first professional job out of Northwestern. I had the privilege of going to Princeton University as a member of their research staff, and my first boss was this guy I never really knew named Lyman Spitzer, who just happened to be, as I found out later, the father of the Hubble Space Telescope. He first proposed it in 1946. So at my very first staff meeting at Princeton, Lyman was talking about his proposal for a camera on Hubble, so I was sort of by osmosis got involved in Hubble from day one. And then by pure coincidence, I wound up at headquarters and wound up being named the program scientist for Hubble, and the rest is history. But along the way, I've been involved in a few missions, PI class, instruments, mega missions, Battlestar Galacticas, all the way back to IUE, EUVE, little mission called Kobe, Hubble, et cetera, et cetera, et cetera, Mars missions, Cassini. I mean, the list goes on. I've seen good PIs, and I've seen bad PIs. And if you really get me loosened up, I'll tell you the difference between the two and what makes the difference. Why are we here? A few years ago, the concept was proposed that PIs need to be trained. In fact, we shouldn't even select PIs if they've never been a PI before, which was kind of a self-limiting way to. I was at Goddard at the time, on my sabbatical. I call it my sabbatical at Goddard for 4 years. Spent the rest of my career at headquarters. Actually, being at Goddard and being a center director gave me a whole different perspective on the way the agency works and doesn't work. I was talking to Charlie Bolin about that yesterday, but I won't go into the discussion. But it does give you a unique perspective. From my 30 years of experience, I found the concept of you had to train PIs before they were even allowed to propose was flawed, because I saw successful missions and I saw unsuccessful missions. Unsuccessful PI missions are led by Napoleons who are told by their smart engineers that attacking Russia in the wintertime is not a good idea. But because they're Napoleons, they ignore advice because they know all, and they move on and make mistakes. Successful missions are led by teams. The PI is a team leader, but a good PI team is not just an experienced PI. It's a good system engineer, it's a good project manager at a center or your contractor, it's a good project scientist, it's a good program scientist at headquarters and a program exec at headquarters. That's the team. If you've got a cohesive team like that, you've got a damn good chance of making things happen. If you know all, and you know better than a NASA center, you know better than a Lockheed or a NGST or a Ball Brothers, you're going to have a difficult time. So, and I'm not speaking hypothetically. I've seen both sides of that. So that's about as much wisdom as I can give you on that point. Let's see. Why are PI missions so important? A lot of people label me as a Battlestar Galactica guy. I'm not really interested in small stuff. Not true. I spent a lot of time defending Explorer programs, Discovery programs, New Frontiers programs. The National Academy doesn't know everything. You know, they're pretty smart people, and they're pretty good at giving us priorities for very large missions. Before, I like to tell a story, you know, why do I preach that the National Academy decadals are my playbook? And I call it a Homer Simpson story. I just told it the other day to the Science Snack. There are two ways you can go testify to Congress, you know, as follows. Congressman Jane Doe, or Congresswoman Jane Doe from Alabama asks you, Dr. Weiler, why are you doing this billion-dollar mission? There are two ways I can answer that. Because I think it's a good idea. As associate administrator, I'm all powerful. Or I can say, because the most respected scientific body on Earth, the National Academy of Sciences in the United States of America, made this mission #1 priority. Now, which one do you think will be a better answer to your, I leave it to you. So it's as simple as that. Why do we preach the National Academy as our playbook? Simply that. I mean, our job at headquarters is to sell these missions. And we want to be sure before we commit $1 billion or $2 billion or $3 billion that we have the blessing of, again, the highest science body in this country. So that takes care of the, the Mars missions, the Cassini's, the, Europa missions, the MMSs, solar probes, things like that. But what about smaller missions? Science does change. I mean, when you lock yourself into a flagship, you're locked in, as you well know, as Lyman Spitzer found out, for about 40, 50 years on Hubble. But even on our more current flagship missions, it's really 10 to 20 years from conception to actual flight in science. Science changes over 10 or 20 years. So we like to have options for smaller missions and the latest scientific priorities. So we have things like New Frontiers, Discovery, Explorers, and even Missions of Opportunity, which are small instruments that can be put on other people's satellites. Those are led by PIs, and we leave it up to the community on every single AO to decide, again, what are the highest science priorities. And that's done at that point in time. So you're taking into account recent discoveries, dark energy or whatever. So PI class missions fall into that category. I'd call them mid-range, $500 million to small, $200 million. And we think we've been pretty successful with these kinds of missions. My staff put together some greatest hits. I'm kind of surprised Colby's not on this, but that's okay. WMAP, certainly, really measured the age of the universe more precisely than even Colby or Hubble. Stardust returned an actual sample back to Earth. Messenger, hopefully the first successful orbiting mission for Mercury. Dawn was the first mission to orbit another planetary body, deorbit it, and then orbit another planetary body, Ceres and Vesta. Near is another example that's not on here, but there's one. That was our first lander on a planetary body, if you call sort of coming in slowly and touching an asteroid landing, but it effectively did that. Kepler. Kepler will be the first mission that detects Earth-like planets. That's going to happen unless a meteorite hits it. Its detectors, its optical system are working to specification. It will detect Earth-like planets if they're there. I have a feeling it's going to detect a lot of them. SWIFT, first mission to really get into the secrets of gamma-ray bursts. Themis, the first mission to understand the causes of aurora. And GRACE, one of my favorite Earth science missions, a PI-class mission in Earth science, which is kind of rare but it's going to be more and more common in the future, was a mission to measure variations in Earth's gravity, but it found a utility that was really unique. It's so precise that it's able to measure groundwater reserves in small areas around the world. For instance, it's shown the decline of groundwater in San Joaquin Valley. Which is not good news for California. It's not good for all of us because of California being so hopefully they can do something about this because it can monitor it continuously. GRACE is so important that we've decided to fly a reflight of GRACE, GRACE 2. So PI class missions have played a major role in our program, not just the flagships. You hear a lot about the Hubbles and the Cassini's, but PI class missions have played a huge role in our overall science program in terms of the balance, filling in the gaps where those flagship missions don't really work. The title of this one is One of the PI Secret Weapons NASA Centers. This may offend some people, but NASA centers do have a role. They've been around for 40, 50 years in many cases, especially places like Goddard and JPL, who are prime science centers. They have deep institutional experience. I didn't really understand Goddard, even though, Goddard was 17 miles north of headquarters. I didn't really understand just how deep Goddard is in experience until I was its center director. Orlando Figueroa, who's going to be talking later, was the director of engineering while I was out there. And he has a staff of like 1,000 to 1,500 engineers, just in his civil service engineers, just in his organization. That's larger than 4 of the NASA centers. It's larger than Ames. And these are just engineers. Okay, Goddard's overall staff's about 3,300 civil servants and 5,000 or 6,000 support contractors. So I liken, people ask me what it was like being a center director. It's really like being a city manager or a mayor. It's a very different job than a place like headquarters. But there's deep institutional experience at places like Goddard, JPL. Centers do something unique for a PI if you're associated with a center. Not only do they help you manage the mission, but the center's got a job which is called independent technical authority. Project manager can go to the program manager, say in the Explorer program, and the program manager can come up to the division director, who can come up to me, and I can decide to cancel a few tests because we're going over budget. Okay, I could do that. Okay, it's the center's job, the independent technical authority job, through the center director, an independent chain of command, if they feel this is really stupid from an engineering point of view. For instance, doing an end-to-end optical test of a telescope. Not that NASA would never, ever do that, right? They can raise that to Charlie Bolden, who's my boss, and then Charlie would have to be the adjudicator between the center director and myself. I don't know if many people realize that chain of command exists. The center has an independent chain of command through the center director, through their engineering director, right up to the administrator of NASA. So that's kind of a checks and balances. In fact, if you look deeply into NASA's history, it's something I always thought was a strength of NASA, is the numerous areas of checks and balances. I just gave you one example. There's a chain of command, the PI, the project, up to NASA headquarters, SMD, all the way up to me if necessary, to make decisions. But then there's an independent chain of command through the center director up to the administrator. Another example is project scientist, project manager. If it's done right, the project scientist doesn't report to the project manager. The project scientist reports up an independent chain at the center to the center director and eventually to the program scientist at headquarters, independent of the project. So if some project manager is doing something bad, it's going to save money, but it's going to hurt science. Not that a project manager would ever do that, right? It's the project scientist's job to take that up his chain or her chain. Checks and balances. These people do not answer to the same people. Just like I don't answer to this, I answer to, well, with the exception when you get to the very top of the pyramid, I answer to Charlie Bolden. The center director answers to Charlie Bolden. Hopefully it never gets up there. In fact, I don't think it's ever gotten up there except for one time when somebody decided to cancel a Discovery mission, if I recall. Well, I was at Goddard at the time, so anyway. Checks and balances, very critical. Public affairs. Now, I was educated as a scientist, PhD and all that, and like all scientists, I know that we know everything. Teaching, we know how to teach. Public affairs, we know about public affairs. Education, hey, we teach graduate students. We know everything there is to know about education, right? Sorry if I offend any of my colleagues, but, the world of public affairs and public outreach is very broad, and there's a lot of expertise in the NASA centers. A lot of expertise. If you don't believe that, go look at that little program called Hubble and how well it's known by the public. Okay, that was a combination of the NASA Science Institute and NASA headquarters that created that public affairs program. If you think Mars is noticed by people, you can give credit to JPL and headquarters again. There's a lot of embedded experience at NASA in how to do public affairs. A lot of people accuse NASA of having bad public affairs because why don't the people love NASA? Well, we still haven't broken the code as to how to get a reporter to write what you want them to write. It doesn't work that way. So the bottom line is I would urge in fact, we're thinking about changing our AOs to reflect this. If you're not taking advantage of the in-depth experience of your project or your program office or the headquarters program people to get help on public affairs planning, education planning for EPO, please do. We're going to make it a requirement in future AOs. Paul is working on that as we speak. It wasn't a requirement in previous AOs, but I think people are missing out if they don't take advantage of what NASA has to offer you. Let's see. PI of each mission plays an extremely important role. You're in charge of the mission. Sort of. Okay. Ultimately, and I think everybody understands this, ultimately, yes, you are in charge of the mission on a day-by-day basis. But ultimately, NASA is the steward of taxpayer money. And if you're doing something that is not in the best interest of the taxpayers' money and the overall program, we can overrule you. I've removed PIs. Not a very pleasant thing, but, you know, back in the 80s, there was a mission where we had to remove a PI because it was disruptive to the program. Don't do it very often, but it's been done. We cancel missions without naming names to embarrass any person not here. We've canceled several missions, competitive PI class missions. Don't like to do it. If we have to do it, we like to do it in Phase A, Phase B, not after we're spending real money, but that's our responsibility. So with the exception of gross negligence and disruptive behavior, PIs are more or less in charge of their mission. We will certainly hold you responsible. You set ground rules and expectations to prevent requirements. One of the really important jobs of a PI is also to be the head of their science team. And I know nobody's ever experienced this, but you get excited, you get selected, you get going, the money's flowing, millions of dollars are coming in, and you're thinking, some of your co-Is may think of this as the last bus to Abilene, and let's get our instrument, let's get this capability on, let's get that capability on. You know, if we polish this rock just a little bit more, we'll get another 4 decimal points out of this measurement. You know, stick to your level 1 specs. That's what you were selected to. You know, don't polish the rock. You know, really, really important. And that is your responsibility, to control your science team. It's also your responsibility, yes, you were selected for a certain level 1 specs. You were going to do something, you know, you were going to get 85% of some number or something. And it turns out you get deep into the project and it looks like to get that 85% is going to cause you an overrun of 10 or 20%. But if you could settle for 80%, you'd be on cost and schedule. Just because it's a level 1 spec at 85%, don't hesitate to go up the chain all the way to me if necessary. I can change level 1 specs with a stroke of a pen. I don't do it very often, but if it's a difference, if it's close enough and it's going to save an enormous amount of money, you know, we can do that. So again, dialogue. You have a route to the AA. You know, I'm not going to be around forever, but there'll always be an AA, I assume, as long as there's science at NASA. Don't hesitate to use that. Bring it to your project manager first, and then take it up the chain. Has to keep the project and project manager focused on achieving success while staying within the box. Same message. I talked about keeping the science team focused. Has to be capable. Hopefully most people that become PIs and have gotten through a proposal writing process are capable of making hard decisions. So you have to continually make hard decisions to control cost and schedule. The PI's ability to effectively lead his or her project can be the difference between success and failure. That's an understatement. So that's about all I was going to say, hopefully to encourage some discussion. We've got another 15, 20 minutes here, and then I'm going to be around until at least after lunch. So catch me in the hallway if you want to tell me something privately, or I hope we'd have some discussion here. So the floor is open for comments, questions, criticisms. Any question, you know, except about human spaceflight, I will not address that issue. It's too hot of a topic right now. So, Come on, there's got to be some, come on. All right.
You mentioned level 1 specs and how you can bring them back from, say, 85 to 80 or something.
Whatever, yeah.
From a project point of view, you want to be 100% sure of making that 80%. So we end up making 300%. You notice that happening?
I notice it a lot. I happen to have a little bit to do with something called spirit and opportunity. And our level 1 spec was 90 days on the surface of Mars. Okay. I learned something about my friends at JPL and building a Mercedes-Benz when I was promised a Ford Escort. I like Mercedes-Benz. Actually, Ford's better now these days. But anyway, it's the job of a project manager. I don't want to put the project manager in a position of tattling on the PI, but if it doesn't cost anything, 300% is great. Love it. Always love more science. On the other hand, if you read the blogs and newspapers, NASA gets more and more criticized for overruns and schedule delays and all that. And we're trying to get around that a bit by being more selective in the early phases. And when we select a proposal now, it's routine that I have 4 or 5 Category 1 proposals to select from, to pick 2 or 3 or 4. And I've been warning that I'm going to do this for a long time, and we've actually been doing it now for the last couple of years, including on this New Frontier selection. Once you're in Category 1, the science is equal. The science is equal. There's no more science discriminator. When you get into Category 1, at the final stage where I sit down with my division directors, that's where you really get into the ratings from the TIMCO panels, cost credibility, technical readiness, management. You get into those other factors. And if I've got a choice between equal science and one is low cost risk and one is high cost risk, I'll tell you which one I've selected, and I have. And I will continue to do that. There is no reason to select high and middle cost risk proposals or technical risk proposals if I've got equally good science in the low cost risk category. So, what we're trying to do is get, especially contractors, and university PIs, to stop thinking they can buy in. We're not going to select proposals that are clear buy-ins anymore. And that message still hasn't gotten out. It's amazing how many proposals we get from very credible PIs and very credible companies that when they get to TIMCO, the costs are just, clear buy-ins. Don't waste your time. Don't waste your time. I don't know, I'm strayed from your question, but I wanted to get that out. Because it's not, we're walking the walk now. We're just not just talking the talk. You want to know why a lot of programs overran 10 years ago? Because we didn't take cost and schedule too critical. We were going for the good sex science, The sexiest science looked the best, and we selected it. I was part of that system. Paul was around in those days. And oftentimes, that really good stuff turned out to be 10 pounds of unobtainium, and we didn't know where Pandora was, if you've seen the movie, So anyway, these days we select proposals with zero, as close to zero unobtainium as we can find. And luckily, we have the ability to make those kinds of choices because we get a lot of proposals. So, of course, I'm talking to the wrong people. You have been selected. So, however, some of you are coming up on a Phase B selection, so don't sell me a bill of goods because we'll see through it. We will see through it. Yeah. Now, that had to spur some questions, right? Yeah, way in the back.
So this is about your topic on public affairs versus education and public outreach, and I just wanted to know if you could clarify, do you consider public outreach things like media relations, external relations? Is that where public outreach effort should be focused? Because there seems to be a philosophical distinction where education and public outreach is really focused on educating, the NASA pyramid, where media relations seems to be a different pot of money and a
Right.
different responsibility in terms of where it comes from inside a project.
Public affair, to me, you know, and it's a semantics thing. Public affairs to me is media relations. Okay, it's just the way I define it. It's clear that centers have unique experience in that. The other part of that is EPO, education and public outreach. I don't consider that media. I consider that working with museums, planetaria, local schools, the Girl Scouts of America. We have actually got programs with them. That's E&PO, education, public outreach. Some universities can handle that a lot better than others. Some companies can handle that a lot better than others. NASA does it all the time, so you can get a lot of help from NASA there too. It's just because you're a university doesn't mean you know all there is to know about education and public outreach. It's all it's supposed to be a team effort, and all I'm saying is that we should take advantage of the expertise where it is. Some people may actually have a better idea than your local institution or your local company. That's all I'm saying. Again, getting away from the idea that the PI is uber alles. You know, the PI is not the ultimate source of knowledge and expertise and leadership. It takes a village. A good program is run by PIs who really value their system engineer, their project scientist, their program scientist. It's a team. It's a team effort. You know, I feel like I'm stating the obvious, but believe it or not, that opinion is not shared by some. You know, I've always believed in teamwork. I mean, I lived through the Hubble servicing mission, the first one, the one that was life or death for Hubble. And thank goodness we didn't have any, dictators. That was probably the best example of teamwork I've ever seen in my entire career. I mean, we had people from Johnson, Goddard headquarters, contractors, working in a badgeless society. And that's what it took for 3 years to pull that mission off. That mission would have never been successful if we had a few prima donnas involved in it. Anyway. Nobody has any questions about current events?
It's easy to judge a mission as successful once it's completed and you have success, but you indicated that occasionally a mission gets in trouble early, phase B, phase C, especially phase B. What might be the metrics that you would look for to tell you this mission is in trouble?
Well, I think of one example, again, without naming the name, but it was an Explorer, and we canceled it, I think, in phase B, Paul. It was a mission that was having technical problems, with part of the instrument. And there are many layers of technical problems, a technical, how to explain this? This particular technical problem, they had no backup, and they had no route to resolving the technical problem in any nominal period of time. And they were burning money like crazy. EVM was 0. Okay? That was actually an easy call. We canceled it. We didn't go forward. There was no reason to go forward with it. We sent them home and said, think about this, work on it for a few years, and come back and propose again. Even in phase B, if you've got technical issues, but you got a path forward, if reasonable independent engineers look at it and say there's a reasonable chance you'll make it, then we probably wouldn't be in a situation of a cancellation. But, I can't, without having a specific case, I can't give you you're talking about an infinite range of possibilities. We don't cancel that many missions because most of the people that get into phase A or phase B are pretty smart. They have pretty good teams. And if there's a solution in the universe, they usually have a way to find it. But sometimes, as I said, we do cancel missions. A lot of times, not too many. These weren't PI class missions. Well, one was, but I can give you specific examples. Champollion ST4, Space Technology 4, was supposed to be a small technology mission, and it was the bust to Abilene syndrome. Everybody started throwing science on it. It was turned into a comet sample return mission in the New Millennium program. It was approaching $300 million in a program that, you know, had missions that should have been $50 million. And, you know, I just canceled it. You know, well, I didn't. Oh, by the way, I don't want to give you the wrong impression. If you think you come to Washington and you become an associate administrator and you've got ultimate power and you can cancel things, yeah, you can. There are two ways to cancel things. Damn it, I'm going to cancel it because I'm the AA. Or before you say that, you make sure that your boss is on your side. You work it with OMB, you work it with Congress, you work it with key members of the science community, maybe the NAC, and when you've got all that network lined up, then you could say, I'm canceling this, and it probably will be canceled. If you do it the other way, you're probably asking for trouble. So I canceled Europa, and I canceled the original Pluto mission, because they were proposed at $400 million when I first became an AA in '98. By about 2001, I remember Colleen Hartman coming to me, you know, with a price tag of $1 billion each, and she said, this was her program. She was the division director of planetary. She said, I can't support this anymore. You know, there's no money for these missions. They're just out of control. What was happening was reality was setting into those two missions. Anybody who thought they could do a Europa orbiter for $400 million, you know, was probably, well, anyway. Its current price is about $2.7 billion, by the way, just to put it in perspective. Pluto was a little closer. When we competed Pluto, we got a proposal, and I don't know, we came in at about $600 or $700 million. Still well below the $1 billion it had reached, you know, the flagship mission. So I don't know if I answered your question. Any other thoughts, comments? Yeah.
First, a comment. I know a number of other government agencies are deeply envious of NASA's successful EPO program, so I thought you'd like to know that. My question has to do with explorers. Back about a decade ago, the plan was to have an AO sort of every other year, and I know that lately the budget hasn't really allowed that. But I was wondering just what the actual desired plan was. Is it still to try to get back to that rate, or is it that not going to happen in the foreseeable future?
Good question. When I left NASA headquarters in 2004 for my sabbatical at Goddard, I left a budget for explorers of about $300 million a year. And it took us 25 years to go from $30 million a year up to $300 million a year. We had an Explorer program that supported a SMEX AO every 18 or 12 months and a MIDEX AO alternate 12, 18 months. We were finally at a sweet spot. We could have spent even more money, and easily, because we get so many Explorer proposals. But anyway, we were chugging along. And when I left in 2004, the President's budget that was in place for 5 years, approved by the OMB and by the President, continued the growth. By 2004, we had doubled. We had doubled the Office of Space Science budget from $2 billion to $4 billion. The growth continued, not as fast, but still it went up a little faster than inflation. Things changed. We got a new administrator and 3 or 4 different AAs over that period of time. And when I came back, basically the budget I had left in '04 had been frozen more or less at that level and then flatlined. So the difference between that new budget in the out years and that budget that we had approved over the last 4 or 5 years is several $billion. Part of that was Explorers. It was cut in half by the administrator and approved by the OMB eventually. That money was put into Constellation. That's the truth. That's not my opinion. You know, those are budgets, federal budgets. Cutting Explorers back that far was, I think, a fundamental mistake. But, you know, what can I say? It takes a long, long time. Explorers, Discovery, New Frontiers are critical programs because they're line items. We don't have to go to Congress to get approval of selections. They trust us to do selections through peer review processes, et cetera. They're really, really good programs to have. People like Charlie Peller and Frank Martin used to have a saying, "Thou shalt never cut the Explorer program." That's like kind of the golden rule. But it was cut. And it's one of my highest priorities if somebody gave me more money, and for me to ask when I do get a chance to ask, because the Explorer program has given us things like IUE, Kobe, I mean, you know, on and on and on, with Swift, all kinds of good, great missions. You're preaching to the choir. It's a sad day that we are where we are on Explorers. We have made a decision because of these budget situations to give up on SMEXs versus MIDXs. We're just, the next AO is basically going to say, give you a cost, you know, basically a cap, propose what you want to propose. If you want to propose something really small, that would be unique actually. Or you could propose up to the cap. That's another message I'd like to deliver. Will somebody please submit below the cap just once? Yeah. And I don't mean 20, you know, if the cap is 468 million, don't come in at 467.8 and say you're under the cap. I'm talking like 300 million, you know. But anyway. Yeah, way in the back.
We used to have Discovery and Scout programs. Now they're merged. Are they coming back again? As you said before, you don't want to cancel something that's a line item.
Scouts wasn't really a line item. It was a part of the Mars program. That's another sad story. When I left in 2004, the Mars program was about $1 billion a year. It's now about 400 million or 500 million. And I won't comment on what was put in its place. But anyway, within SMD. I had a fundamental, this is the kind of choice I do get to make. I came in 2008 and had an MSL that was in severe overrun situation. There was the budget du jour. Every 6 months the center would come in with a new budget because of technical problems. And these weren't center problems necessarily. In fact, they were commercial. The commercial vendors were not delivering things that worked. Didn't matter if they're on time or not, they didn't work. Actuators, for instance. It was a real problem. So, believe it or not, I'll get to your question about Scout, but I got to give you the context. So, summer of 2008, a budget was given to us, and the center said, okay, this time I think we got it. We'll know for sure by January of 2000, is it 2008 or 2009? Yeah, we'll know for sure by January of 2009 if we're going to be able to make the launch in August of 2009. So give us a chance, let us march down this road, give us, you know, $20–30 million more, and let us, and I said, okay, but we're not going to wait till January, because if we get to January and we keep marching, we're spending 09 money that we don't have, and we're going to have to impact other programs. So to make a long story short, Doug McKiston was told and got JPL to put milestones, monthly milestones from June, July, August. Make a long story short again, we got to Thanksgiving. It was clear, because we were reviewing this on a bi-weekly level, it was clear we were not making the milestones. There was no way we were going to get to August of 09 and actually launch it. So we pulled the plug 2 months early, and we actually saved money for a change. The worst scenario would have been if we just didn't pay attention and let them get to July or August of 09, spending all that money rushing to launch and then saying we can't launch. That would be the worst, most wasteful way. So we probably saved $100 million of 09 money. Admittedly, we built in another $400 million of overrun because we had to delay it. But that $400 million would have been there anyway if we kept marching to launch, plus the $100 million we'd have wasted, if you understand the math. So we pulled the plug and we delayed MSL. Because of all the previous overruns, because of those the launch extension, it became very apparent that the desirements of the U.S. Mars community for a 2016 Science Orbiter and a 2018 Lander, U.S. only, were fiction. They're actually fiction. We didn't have 60 or 70% maybe of the budget that would be needed. This was all hitting at the same time that David Southwood, my counterpart from the European Space Agency, was, in fact, it was this hotel. Or maybe it was, I don't know, one of the hotels in Annapolis. We're for a bilateral. We have a yearly bilateral with ESA. And he was telling me, we were having coffee in the break, and he was whispering in my ear about his problems on ExoMars. You know, Europe doesn't have a program. They do one mission at a time. And ExoMars was a major Mars mission, and he was discovering his Mars scientists, and I know this is a shock, were just adding requirements and adding instruments. He was up to 30 or 35 instruments on this one Battlestar. And he says, I don't have the money for this. You know, he was 60, 70% of the money for that mission. And we kind of came to the conclusion, you know, almost laughingly, you know, maybe it's time, as much as we've really enjoyed competing with each other and getting one up on them and they get one up on us, and we have a bigger flag on our mission than you're, you know, maybe it was time that since, you know, a unique thing had happened, our American community has the same Mars goals as their European community. We have the same long-term goal of Mars sample return as the holy grail of Mars science. Why don't we consider working together on these missions? And he said, yeah, that's an interesting thought, but ESA will never do a program. They only do one mission at a time. But I'll try. I'll talk to some people. Well, we went another year, and we got to Plymouth, England last summer. And we sat I had my people there, Doug McKiston. He had his people there, like Marcello. And he and I sat at the end of the table, and our team just fought with each other for 2 hours over dinner. You know, absolute demands. We will not, you know, give in on this demand. We will not give in on this demand. So at the end of dinner, David and I said, fine, neither of us have a Mars program. Then the next hour, they spent negotiating. If only Congress could do this. Anyway, they actually got together, and by the time we left that 3-hour dinner, we had what amounted to agreement on the first 2 missions in a program. And to fast forward, we went from Plymouth, England in June with a concept on a view graph to Dordan, the head of ESA, and Charlie Bolden, the head of NASA, signing a memorandum of agreement on a Mars program, which is, you know, this never happened in science with ESA and NASA. We now have a Mars program together. Scouts had to fall out of that because we didn't have enough money for Scouts 2. So we made Scouts Mars available in the Discovery program, just like we made the Moon. Okay, let's the science community determine what's the most important thing. So that's a very long way of saying, yeah, we had to sacrifice Scouts, but we saved a Mars program. We don't have a U.S.-only Mars program anymore. ESA doesn't have a ESA-only Mars program. What we have is a Eastern and Western Atlantic Mars program, which may actually get us to a Mars sample return someday, because there was no way this country was going to pay $6 to $8 billion for a Mars sample return by itself, and vice versa in Europe. So I think a Mars sample return mission now is closer than it's ever been. You know. Yeah.
Ed, you've been waxing quite eloquently on the strengths and value of the small missions. One of the things I hear in the community a lot is the need for a balance between small and big missions.
Mm-hmm.
The science objectives we've put out for the program, some of them require the big missions, Mars sample return, Europa, EJSM, and so on. Can you comment on where we are with regard to balance between the small and the large, and how you think we can move forward given the tight budget constraints we face?
I am so glad you asked that question, because I was actually shocked, because I was a believer in the urban legend out there. The urban legend is that as time has gone on, NASA's gotten more and more into the flagship mission. We're spending, JWST is eating the lunch of the astronomers. Mars is eating the lunch of planetary. One of my scientists was actually smart enough to be a scientist and actually gather some data to test this urban legend. I know this is something in Washington you don't usually do, you know, but Eric Smith, now we only did this for astronomy, but I've asked Jim Green and others to do it for their things. Back in the good old days, the great observatories, Charlie Pellern's great observatories, astronomy, the astrophysics division was spending a little bit more than 60% of its budget on flagship missions. Fast forward to today, astronomy is spending about 40% of its budget on flagship missions. Okay, so balance has actually gotten better. You know, now if you're a fan of flagship missions, this will be bad news for you. But if you're a fan of the urban legend that NASA's just getting more and more and more into the flagship missions, it's just the opposite, at least in astronomy. I suspect it's that way in planetary. In fact, it might even be more that way in planetary, because when I look at the budget, Europa doesn't have a budget. I mean, we're going to have to carve out money to get a Europa mission. Mars, I don't know if you call those flagship. Certainly MSL is a flagship. I'm not sure the follow-on missions are. But the big chunks of money are in New Frontiers and Discovery, Lunar, RNA. You know, in fact, I'll bet you it's even smaller than 40% in planetary, but I would appreciate the numbers, Paul, if you can dig them up someday. So, you know, you're right. I mean, but yeah, how could he not believe in balance? I mean, you can't have all your money going into flagships. On the other hand, you can't have all your money going into CubeSats, because Charlie Bolden is very refreshing, because he totally agrees with my viewpoint of what NASA should be. Some people think we should be about more science. I don't want more science. I want the best science. That's what NASA should be. We should do the best science. The best science in small, medium, and large, not just more science. We could do more science by giving every university professor a CubeSat. 10 pounds and you can do whatever you want in space. You know, that's not going to necessarily further our community. You got to have, as somebody said, you got to have the Hubbles, you got to have the JWs, you got to have the MSLs, you got to have the Europas, but not at the expense of you know, opportunities and discovery, explorers, missions of opportunity and explorers or discovery, etc. So I don't see that changing. You know, if anything, we've gotten away from flagships and moving more towards small and medium size. In years.
That's really my question about what is the proper balance, and do you think we're there today?
I think the proper sweet spot's probably in the 40 to 50% range. I think 60% on flagships was too much. You know, even though it did give us the great observatories, but you know, I think 40 to 50% is about the right number. Any other questions? Yeah. Wait a minute, we got a new guy. Sorry, you already had one, so. Unless it's a compliment, then you're, you know.
Do you see any changes in how we're procuring launch vehicles to try to prevent a delay like SDO had that was over a year?
Good question. I have to be careful, because I really promised myself I wouldn't get into the commercial side of arguments of things. Right now we've got a real problem. Okay, we used to have Delta 2s for reasonable cost. We don't anymore. Although there's some rumor they may be making an offer, but we'll see. But there are only 4 Delta 2s left, I think, anyway. So what does that leave us? That leaves us as Pegasus XL, which is a few hundred pounds, the Taurus 1, which is a little bit more than that, but nowhere near a Delta 2. The next bump up is an Atlas V, and the prices are skyrocketing. I can't even tell you what the current price is, because it changes. You know, Delta 4 is even more money. We look forward. I'm a great believer in competition. I hope Elon Musk succeeds and succeeds and succeeds, and more importantly, the quoted price he's telling us now stays the quoted price. And I'm sure it will, just for the record. And I'm sure it will if Taurus 2 succeeds. I also hope that our friends at Orbital succeed with the Taurus 2. These will give us opportunities in the small delta range to the heavy delta range, Delta 2 range. It'll be great. We're with the Air Force. I think I forget the status of the deal, but we're trying to get a deal where Atlas V can launch more than once every 2 months, but actually expand its range, expand its personnel and all that, so they can launch once every 45 days or something. Yeah, I mean, we have to realize we're scientists. We're not national security. We're not people making a profit, commercial. You know, we're at the bottom of that priority list. If you're national security, as you should be, your first priority. If you're commercial, launching a ComSat or something, your second priority. If you're science, whatever's left. And we found that out on SDO. SDO was ready to launch in November, December, a year and a half ago. It was delayed 14 to 15 months. And we, the science community, had to pay $4 or $5 million a month to keep the SDO team alive and waiting and launch team. That's not a good situation, but I don't know what you do about it, other than try to get more Atlas V capability, at Kennedy, and get some competition out there with Falcon 9 and Taurus 2. Those are the only options that I see right now. I don't know of anybody else building ELVs. For New Frontiers, I guess we're on Atlas V's, right? And Discovery, I don't know what the launch vehicle is going to be.
The contract's not out yet, so we don't know either.
Yeah. So I can't tell you what the expected launch vehicle will be for the next Discovery AO. We got a Falcon 9 test flight coming up, I guess, next week, right? Something like that, supposedly. And Taurus 2 is next year, I think, early next year. But anyway. Late this year? Right. So it's a real issue, there aren't any. We're at the mercy of the commercial world. We really are. Yeah.
Sort of a follow-up to Bruce's question. You talked about the role of the NRC in advocating for New Frontiers and for flagships, but what about the smaller missions, the Discovery missions? Is that primarily from the science community, the success of past Discovery missions? What's the background and advocacy for those missions?
Not sure where you're going with that, but the NRC luckily doesn't. I don't think the NRC ever should tell us which Discovery missions we should pick. That should be up to because the NRC only meets once every 10 years. So I don't want to be picking a Discovery mission 9 years after the decadal that's based on something they told me 9 years ago. So that's why I think peer review is the right way to do it. So we select Discovery missions specifically based on open competition and peer review. And regretfully, we only usually select 1 or 2 to fly, and we have how many proposals usually in Discovery, Paul? 30 to 40. So the chances of success are pretty slim. So by the time we get to the final 1 or 2, they're pretty damn good proposals. But that's done by peer review. That's not our, The peer review usually winds up giving us, after all these committees, 4 or 5, out of the 30, maybe we're in the area of 5, 4, 6 Category 1 proposals. Category 1 means your outstanding science, you at least have a shot at the technology and the cost, and a lot of variation in there. So then we get together with the division directors, and we actually have to narrow it down. If we're selecting 4 for study and we have 6, we have to get rid of 2, that kind of thing. And then we do what we did on New Frontiers. We've got 3 in study, and then we'll get in-depth study reports from Phase A, and we'll narrow it down to 1. So the final thing isn't done by peer review. It's done by cost and technical reality. Because again, the proposals are supposed to be equal scientifically by the time they get selected. You look quizzical. Okay.
That gave you a platform to, is this on? So you talked about the role of NRC in helping you advocate in Congress for the larger missions.
Yeah, that's the decadal surveys, right?
Right.
Okay.
So, but we want to keep a balance between smaller
Right.
missions that aren't advocated by the NRC and the bigger missions.
Missions or mission lines?
Right.
No, right to what?
Well, mission.
That was a question.
Do you think there's any threat to mission lines for smaller missions, Discovery and so forth, or is that just Congress is happy and?
No, I specifically told Steve Squires the following. Steve's an old buddy. We had something in common called spirit and opportunity. So we can speak bluntly. I said, don't come to me with a recommendation, the National Academy, decadal, that says we want you to do Europa, we want you to double Discovery, we want you to double New Frontiers, and we want a moon program, and we want RNA. That's a totally useless and erroneous and irrelevant decadal, okay? Because there ain't no money, to be blunt. Money right now for a Europa mission, period. Okay, because the budget's been cut over the years. If you want a Europa mission, I'm just picking on Europa, let's say a Titan mission, whatever you want is your first priority. Tell me what other programs in the planetary portfolio shall be cut or eliminated. Discovery, New Frontiers, Lunar, your choice. But I got to balance a budget. A report that just asks for more is irrelevant. Now, if they feel that Discovery and New Frontiers are sacrosanct, then they should say that and cut something else. There are other things in the planetary budget to cut to get a Europa mission. So I expect the decadal, I hope I answered your question. Now, I expect the decadal to tell me what is the relative priority of a Discovery program, of a lunar program, of an RNA program, of a astrobiology program, of a New Frontiers program, of a flagship program. So knowing Steve, he's going to try to deliver that. It's not going to be easy. Getting 100 or 200 PhD planetary scientists to make those choices is going to be interesting to watch. But that's what the planetary decadal is all about. I hope, did that answer your question? Okay. I happen to hope that New Frontiers and Discovery are maintained at some level because they're extremely successful programs. I would be surprised if they really tried to do any damage to those just to get something new. But, I'm not the National Academy. Okay. One last question, Steve. Did you have a... Yeah, you're...
Recently, the president presented an outline for kind of redirect NASA, which ended up with asteroid. Have you seen anything as science was doing in the past for like heads and lunar exploration that leads toward paving the way for that?
Yeah, there's a thing in the exploration, ESMD it's called, exploration, what's the S stand for? System. Okay. Budget called Robotic Precursor Missions. Okay. Now, and there was $3 billion over 5 years. This is totally out of SMD's arena. That money was for robotic precursor missions to do survey work, recon, in situ resource utilization, prepare the way for human exploration. That was in the budget before the president's speech. Okay, remember the first budget in February basically kind of canceled Constellation and all the things in Constellation, Ares 1, Ares 5, Orion. All right. The thing that the president talked about was kind of a compromise in that first budget. Orion's now going to be maintained. Okay, some aspects of Orion are going to be maintained. And NASA's now got a role in the heavy lift vehicle. How the budget's going to be reordered to take into account that and where robotic precursors budget will be, I don't know. That's beyond, well, it's not above my pay grade, it's outside of my pay grade. It's a different organization. One thing that's clear, though, there's going to be a separation between robotic precursors and science, as there should be. Okay? Just because this is a very important point, and I may or may not win this point, but just because somebody's going someplace doesn't mean that's the best place to do the science, if that makes any sense. Remember, SMD is supposed to do the best science, not just more science. If somebody's going to asteroid XYZ, and they're doing it for recon because humans may go there someday, doesn't mean I want to spend $100 million to do quote-unquote science on that asteroid, because it may be an asteroid of a type that we've studied many times and there's not a lot of new science to do. I'm just hypothesizing now. However, if they decide to put an orbiter around Mars to study something that humans want to know for human exploration, I would love to put a X-band and a Ka-band transmitter on that to be a relay system for our science missions that'll be on the surface. That would be a good, to me, that's the classic example of a good collaboration between ESMD and SMD. If they're going someplace for one purpose, we find a way to work with them to do something that's going to be important to us and to them, frankly. Right now, when MSL gets to Mars Science Lab gets to Mars, it's going to depend on Odyssey and MRO for relay links. Well, Odyssey is going to be 10 years old by then. MRO's going to be pretty old. You know, we used to have a thing called the Mars Telecom Orbiter, which was slashed and cut and burned with, again, that black hole period when the budgets were things. So anyway, I'm rambling here, but there are good things we can do with ESMD. I just hope we don't get into a scenario where, and I don't think I know Charlie wouldn't do this. We're not going to be directed to do nice, good science with money that we could be spending on great science. Okay? Because I'm a firm believer, you don't do, just because somebody's going someplace doesn't mean that's the best place to do science. If that explains it. Is that a better way to say it? You know, clearly if they're going to Mars, we want to go with them because there's a lot of science to do on Mars. The case gets more fuzzy when you talk about certain kinds of asteroids. NEOs are very interesting. You know, that's one example of where we might be interested. Asteroids that we've already flown by of the same type might be interesting, but is it the best use of our limited science money? I mean, people want to do Mars Scouts. They want to do discovery missions. It's all a trade-off. It's a zero-sum game. If I spend money on, this is the key point, I cannot put science instruments on ESMD precursors with their money. If I want to do science on those missions, I have to pay for it. That is, you have to pay for it. It's money out of New Frontiers or money out of Discovery. So that's why I guard that very carefully. Okay, I think we're over time, right? All right, who's next?